morning. I am Renu Sharma, Assistant Professor, EC Department. Today I am going to start with the next part of Unit 5. Now that is related to ASK, FSK, PSK, its modulation and demodulation diagrams, and we will see its detailed description. Next is why do we need digital to analog conversion. So, in the previous lecture we have discussed about D to A converter, that is QAM is one which we have discussed in detail. So, now there is a question that why we actually need D to A converter, because at the transmitter side we have already converted the analog signal into digital. So, also D to A converter is there, because most of the information or all of the information you can say which is stored in the system is in the form of digital data. Now, to access the speech signal or to access the actual information which is in the form of analog, we require A to D and D to A converter. So, you can see in this diagram that whatever data you want to transmit, it is first being accessed by this particular sender which is generating this digital data. Now, it is applied to this modulator. The output of this modulator, since it is a D to A converter, it is a kind of analog signal. This analog signal will travel over various devices, you can say, or channel. Then it will be applied to this demodulator. At the demodulator, the output will be a digital data and it will be sent to a receiver. So, the medium or channel is band pass. The multiple users need to share the medium. So, basically that is a concept that that particular single medium, since it is a multiplexer kind of concept, so only a single channel is not set up between two users, single channel will be set up for multiple users. So, that traffic will be of different type. It can be, sometimes it can be a speech signal, sometimes it will be a message that you want to transmit. So, that is why since the variety of data will travel over a single channel, so this type of conversion is beneficial. So, types of D to A converter, this is ASK, FSK, PSK. Now, first we will see ASK in detail. So, ASK is the strength of carrier signal is varied to represent binary bit 1 or 0. So, both frequency and phase remains constant. So, that thing you have to keep in mind, that whether it is ASK, FSK, PSK, two of the parameters has to be kept constant. It should not be varied, whereas in case of this PSK, other two parameters. So, that is the concept which is followed in any kind of modulation, whether it is analog or whether it is digital. So, in case of ASK, we are considering amplitude has to be varied and phase and frequency will be constant. So, this is how you can see that for binary bit 0, this will be the amplitude, that is A naught cos 2 pi fct. For binary bit 1, it will be A1 cos 2 pi fct. Now, if you want to draw the waveform for this one, let us say this will be 1 0 1 0. So, this will be the value, which means this is 0 volt, this is V. So, for bit 1 you are considering a voltage level, this is a kind of line coding only. For 0 you are transmitting 0 bit, again for 1 you are transmitting voltage V, and for 0 you are transmitting 0 volt. So, that is the case. So, corresponding to that, if you want to make a ASK waveform, so ASK is also known as OK, that is on off keying. It will act as a switch, like for if you want to transmit bit 1, then pulse will be transmitted, and if you want to transmit 0, then 0 volt will be transmitted. So, that is the waveform of ASK. Now, next is demodulation. So, only the presence or absence of a sinusoid in a given time interval needs to be determined. So, advantage is that its simplicity. Disadvantage is ASK is very susceptible to noise interference. Noise usually affects the amplitude. So, therefore, ASK is the modulation technique most affected by the noise. So, frequency and phase will be kept constant in case of ASK, only you have to vary the amplitude. So, that is why the case we have to consider that noise will mostly affect the amplitude of the signal, and we are changing only that, we are considering only that information. So, definitely there will be a noise which you have to consider in ASK. Application of ASK, it is used to transmit the digital data over the optical fiber. So, there are three types of wired channels are there, that is optical fiber is there, twisted pair cable and coaxial cable. So, depending on the application you can consider any one of it, and mostly optical fiber cables are used for ASK. This is a simplest kind of diagram. You can see that these are generated by line coding, that is unipolar NRZ. It is multiplied using this oscillator output. This will be the multiplier, and you can see for bit 1 you have to transmit some pulse, for bit 0 you have to transmit 0 volt. So, that is how you have to consider the ASK modulated wave. Now, this is digits carrier signal. So, you can see that this is having very high frequency as compared to the VDT, which is the main aim of modulation, that you have to superimpose the actual information onto a carrier signal which is of very high frequency. Then after multiplying these two signals you are getting this kind of information, because when 0 is multiplied with any voltage you are getting 0 volt. So, this is how very simplest kind of block diagram that you are seeing to generate the ASK signal. Now, next is this one, that is VDF and VCF. VDF is nothing, it is the how does the frequency spectrum of VSK look like. So, this is how this spectrum will be there. Next is ASK frequency spectrum. So, you have to consider its derivation, mathematical representation before drawing its frequency spectrum. So, this is the carrier signal, that is VC cos omega CT, where cos omega C can be represented by 2 pi FC. Now, this is the digital signal which is unipolar in nature. So, VDT will be is equals to A multiplied by half plus 2 upon pi cos omega naught t minus 2 upon 3 pi cos 3 omega naught t plus cos 2 upon 5 pi cos 5 omega naught t. Now, after multiplying these two signals we are getting a modulated signal which is VASKT is equals to VCT into VDT. So, after multiplying you can see that there will be sidebands will be generated, that is upper sideband and lower sideband, and a center frequency will be there. So, this is how you can see that this is the center frequency where the amplitude is maximum, because we are having carrier signal which is having maximum amplitude. These are the sidebands which is having decreasing amplitude, and this will be the spectrum of the signal, output signal, and this is the spectrum of the digital data which is unipolar in nature, and you can see that this frequency is quite high as compared to the omega d maximum. Now, next is FSK. So, frequency of carrier is varied to represent binary 1 or 0. Peak amplitude and phase remain constant during each bit interval. So, we are seeing that ST is equals to A cos 2 pi f1 t for representing binary bit 0 and A cos 2 pi f2 t for representing binary bit 1. So, this is how you can draw the particular waveform where two frequencies are considered. One is having higher value, other one is having lower value. So, you can see that for transmission of bit 1 higher frequency is considered, for transmission of bit 0 lower frequency is considered. Demodulation is demodulator must be able to determine which of two possible frequencies is present at a given time value. Advantage is FSK is less susceptible to errors than ASK. Receiver looks for specific frequency changes over a number of intervals, so the voltage spikes can be ignored. Disadvantage is that FSK spectrum is 2 times of ASK spectrum. Application is it will be used for voice lines, high frequency radio transmission. So, basically if you want to transmit the speech signal where the variation is there in terms of frequencies, so FSK will be used. Now, this is the waveform which is showing that how this will be generated. So, this is the digital bits, that is 10110001. Now VC1T is nothing, this is the carrier signal. So you can see that this is having a very high frequency as compared to the data. Another more higher frequency will be considered for VC2T. So you can see that for bit transmission 1 we are having this, for transmission of 0 bit we are considering VC1T. When we are going to superimpose this information, we are having this FSK. So how this is actually done, you can see that two different frequency carrier signals are there. So this is done using summer, and before this summer there is two modulators are there. One will going to modulate on the VC1T signal, and other signal will be modulated on VC2T T signal. Then output of these two signals will be added together to find out the VFSK signal. Now you can see in this spectrum also that omega 1 is less frequency having and omega 2 is having higher frequency, and these are modulated together. So higher frequency term is used for the transmission of bit 1, and this one is used for the transmission of bit 0, and that is how this omega 2 is quite high, omega 1 is lesser than omega d, that is the digital data frequency. Now next is FSK modulated signal, that is frequency spectrum. So this is the digital signal. This digital signal is modulated with value omega 1 and Vd dash t, that is modulated with omega 2. So modulated signal will be FSK t is equals to cos omega 1 t Vdt plus cos omega 2 t 1 minus Vdt. So this is how you can going to simplify the equation, which is having larger number of side bands, upper side bands and lower side band. Next one is PSK. So PSK is a case where only phase of the carrier signal is changed proportional to the amplitude of message signal. We are not considering the, we are not changing the amplitude and frequency of the carrier signal. So peak amplitude and frequency remains constant. Example is for binary 1, we are shifting the carrier signal with having 0 phase shift, and 180-degree phase shift will be provided for the bit 0. A PSK is equivalent to multiplying the carrier signal by 1 when information is 1 and by minus 1 when the information is 0. So ST will be is equals to A cos 2 pi FCT for binary 1 and A cos 2 pi FCT plus pi, means 180-degree phase shift will be there. This is equivalent to a minus cos, means when we are going to shift 180-degree in the cosine, it will be equivalent to negative signal of the cos. Now next this will be bit 1, then this will be 0 1 1 0 1. So this will be plus A amplitude and minus A amplitude. So demodulation is, demodulator must determine the phase of the received sinusoid with respect to some reference phase. Advantage of this is PSK is less susceptible to errors than ASK. While it requires or occupies the same bandwidth as ASK, disadvantage is that more complex signal detection and recovery process is there, because since the phase is changing every time, that is much more complex as compared to the amplitude and frequency. So that's why we are considering the phase. So now this is the phase of the signal, where Vdt is the digits, this is the carrier signal, this is the modulated data. Now this will be multiplied using this binary data, it will be multiplied using this oscillator circuit, and we are having this phase modulated signal. So omega c will be the center frequency, this will be upper frequency band, and that will be the lower frequency band. Now next is PSK detection. So PSK detection is multiply the received or the modulated signal, that is plus minus A cos omega ct by 2 cos 2 pi FCT. So the resulting signal will be 2A cos square omega ct for binary bit 1. and minus 2a cos square omega ct for transmission of binary bit 0. So, by removing the oscillatory part with a low pass filter, the original baseband signal can be easily determined. So, this is how you are going to detect the PSK waveform, where input signal is AK cos omega ct. This is multiplied by 2 cos 2 pi f ct, and this will be the output of PSK detector. Now, this is the sender part and this will be the receiver. Now, you can see that two signals will be transmitted, and when this is the same signal that we have received, we have to reconstruct the original signal, which you can see is shown by this red color line. So, how we are going to do it? The signal shifted above or below the 0 level. So, that is the case. So, after multiplication at the receiver, xt cos omega ct will be generated. So, this will be plus a and minus a. This is how the variation will be there. And next, this is the baseband signal after smoothing effect is being shown. Now, next is facts from the modulation theory. So, since we have learnt about different types of modulation, that is analog and digital both kind. So, if the baseband signal xt with having bandwidth omega c by 2, then the modulated signal has bandwidth of omega c hertz. So, this is how the data rate will be there, that is 2 into omega c by 2, that is b, and this is the variation. So, if the band pass channel has bandwidth of omega c, then the baseband signal has the bandwidth omega c by 2 hertz that is available. So, that is the main criteria for modulation theory. Next is the QPSK, that is also known as 4PSK, because we are considering 2-bit combination, and when 2 bits are considered, so 2 to the power n means 4 options are there, that is 0 degree, 90 degree, 180 degree or 270 degree. You can also consider in these 4 quadrants also. So, it will be minus 3 pi by 4, minus pi by 4, plus pi by 4 and plus 3 pi by 4. Advantage of this is higher data rates than PSK is there, while bandwidth occupancy remains the same. 4 PSK can easily be extended to 8 PSK, that is NPSK. However, the higher rate PSK schemes are limited by ability to equipment to distinguish small difference in the phase. Now, last topic is the QAM. So, it uses 2-dimensional signaling for transmission of bit 1 and for transmission of bit 0. So, this is how you are going to generate. First, it will be multiplied by 2 different locally generated carrier signals, then this will be added together. This is how you are going to generate the transmitted signal that you want to transmit. The advantage is that its data rate will be 2 bits per bit interval. This is how the waveform will be generated for QAM. QAM demodulation means 2 different again carrier signals are there. These are passed through 2 low pass filters, and the higher frequency terms will be filtered out. As you can see that cos 2 omega ct will be filtered out on only the lower frequency terms will be there at the output of this QAM. Last one is signal constellation diagram. Now, you can see that in this case for ASK we are having 2 bits, for BPSK there are 2 phases are there. So, that will be before the origin, after the origin, and this is how this 4 QAM will be there. For 4 points are there in this constellation diagram. Next is 16 level QAM. When the number of points are increased, then this will be AK bit will be there, this will be BK. So, this is somewhat like a square only. This is all about today's lecture. Thank you.